All right, today we're going to be doing Essential Standard 2, Learning Target 6B over geometric proofs. So we're going to dive a little bit further into geometric proofs. On the last video, you learned kind of what it means to prove something in life in general or in math. So for example, if you wanted to prove that an angle was a right angle, you could get out your protractor and measure it, and if it was 90 degrees, that means that you have proven that it is a right angle, because we know that right angle measures 90 degrees. So there's a few things we need to know about something called a proof. So when we write proofs, we have to have justification for everything that we say. Oftentimes, you have some type of hypothesis, something you begin with, and then in the middle, you're going to use definitions, postulates, properties, theorems, to try and prove something, a conclusion. So for example, if someone rear ends your car on the highway, you would need some type of proof to show the insurance company. Maybe it's a police report, or maybe the insurance company would need to see pictures that the back of your car is damaged and the front of their car is damaged. So for everything that happens, we need to have proof that that is true. So when we write a proof, we use definitions, postulates, properties, and theorems and math to kind of state what we're talking about. So a few of them that are going to come up here, one of them is called the linear pair theorem. For some reason, it's called a theorem here. I often see this called a postulate, not that it's a big deal, but I think on your cheat sheet, it says the linear pair postulate. And it says, if two angles form a linear pair, then they are supplementary. And that makes sense. We know that a linear pair is two angles that when you, they form a straight line. So for example, if we had angle A here and angle B here, they are adjacent, which means they share a side in the middle. And they're two sides that are not adjacent. So the bottom of A and the bottom of B form a straight line, which obviously we know straight lines are supplementary. Two angles that form a straight line are supplementary because that is a straight line. The next one is the congruent supplements theorem. It says if two angles are supplementary to the same angle, then the two angles are congruent. So I'm going to kind of draw a picture here so that makes a little bit more sense to you. So if I have one angle, maybe like an acute angle, and then I have a larger angle, an obtuse angle, and I'm going to say these are supplementary. That means they add up to 180 degrees. So let's say if this is 150 degrees, that means this one would have to be 30 degrees because that would be 180. And then there's another angle that is also supplementary to 150. So if we have another angle that's also supplementary to 150, that angle would have to be 30 degrees. So you can see that this angle and this angle are supplementary, but also this angle and this angle are supplementary. What do you notice about these two angles? Well, they are congruent. That means they have the same measure. So once again, if two angles are supplementary to the same angle, that means that two angles are congruent. That's what that theorem says. So when that comes up, you can just say congruent supplements theorem. And you don't have to have it memorized. You'll have kind of a little cheat sheet with all the definitions and theorems on it. But if that ever comes up in a proof, you now have a theorem that states that that is already true. The next one, the right angle congruence theorem. It's pretty obvious. Basically, it says if you have two right angles, then they are congruent to each other. It's kind of like a duh theorem. So if we have two right angles, obviously we know a right angle measures 90 degrees. And if they both measure 90 degrees, then they are congruent. So it kind of takes one step out of the mix. Instead of saying they are right angles, so therefore they're 90 degrees, they are 90 degrees, so therefore they are congruent, or they are the same measure, therefore they are congruent, you can just say all right angles are congruent using this theorem. And then the last one is kind of like the congruent supplements theorem, but it's the congruent complements theorem. And it says if two angles are complementary to the same angle, then the two angles are congruent. So I'm going to kind of show you another picture here. Complementary just means that they add up to 90 degrees. So let's say we have kind of two angles here. Let's say that this one is 60 degrees. That means this would have to be 30 degrees in order for them to add up to 90. So one angle is supplementary to another angle. And that 60 degree angle is also, complementary, 90 degrees. That angle is complementary to another angle. Obviously, if that one's 60, that one has to be 30 for those to add up to 90. So once again, two angles are both complementary to the same angle. So therefore, these angles are congruent. You can see they're both 30 degrees. And that's what this is saying. All right, now here's just a look at your geometric proof properties kind of cheat sheet. You will be able to have this on your test, but go ahead and get that out. It's in your packet. It says definitions are already accepted to be true. So many times you do not have to spend the time proving something because it's already been defined or it's already been proven. So instead of doing the dirty work, you can just pull one of the definitions that already states that to be true. So for example, if I'm trying to prove that a linear pair of angles sum to 180 degrees, which two lines on your proof property sheet would we use to prove that? So what I typically do is find that vocab word first. So linear pair. So let's look at your cheat sheet here. Linear pair is right here. It says if two angles form a linear pair, then they are supplementary. Well, that's nice, but I don't want to prove that they're supplementary. I want to prove that they sum to 180. So next, what you can do is find the definition of supplementary. And it says the definition of supplementary angles is two angles whose measures have the sum of 180 degrees. So by using these two lines, the linear pair postulate and the definition of supplementary angles, we can show that if it is a linear pair, then it's going to sum to 180 degrees if you kind of puzzle those two together. So we're now going to use this sheet here to fill in the blanks for a couple proofs. Basically, we're going to write the justifications for the steps that are being shown to us. So it says, write a justification for each step, given that A and B are supplementary. So they're telling us that this angle is supplementary to this angle. And we do know that the measure of angle A is 45 degrees. So that's what that means right there, the little m. That means the measure of angle A is 45 degrees. So the information that they give us is always the first step, and we call that the given information. That's what we are given from the start. But you can see our goal down here is to somehow create a train of thought that leads us to the fact that the measure of angle B is 135 degrees. So, the first thing we're going to do, we need to come up with the missing reasons. So these are the statements and these are the reasons, the justification for each statement that's being said. So the measure of angle A plus the measure of angle B equals 180 degrees. Well, what I do typically, there's usually some vocabulary word in the given information, and they tell us right there that they are supplementary. So if you go back to your little cheat sheet here, remember, supplementary means that the two angles, sorry, the computer's being a little weird here. The two angles sum to 180. Remember, sum means add up. So that right there is the reason for us being able to do this. We can add them up because the definition of supplementary says so. because they are supplementary, they sum to 180 degrees. Okay? Now, from step 2 to step 3, you might ask yourself, what's different? It's very similar. You'll notice that measure angle B, measure of angle B, 180 to 180. But measure of angle A suddenly turns in to a measurement, 45 degrees. And if you notice, that's one of the things that they told us from the very beginning. So that is actually our substitution property. If we know that two things are equal, we can substitute one in for the other at any point. So if I know that the measure of angle A is 45 degrees, then instead of writing the measure of angle A, I can write 45 degrees at any time. So that is the property of substitution. And then the last one, once again, I always ask myself, what's different? How did they get from here to here? So B is still there, the measure of angle B. But notice, for some reason, the 45 is gone now on the left side. There is no more 45 here. And the right side is smaller. You might notice that this is exactly 45 degrees smaller. So what happened here is they subtracted, kind of like you did in Algebra 1, a subtraction property of equality. If you subtract 45 from both sides, 45 degrees, then B is by itself, and 180 degrees minus 45 degrees is 135 degrees. So we have just proven that the measure of angle B is 135 degrees. So that right there was actually a subtraction property of equality, PO. And we're now done with our proof. We have a statement for every reason. We have a reason for every statement that says why it's okay for us to make that statement in math. And once again, those all come from here. And you can use this as much as you want. In fact, I suggest that you use it as much as you can to help you out. All right, a couple more here. It says, write a justification for each step, given that B is the midpoint of AC. So we know that B is the midpoint of AC. And AB is congruent to EF. So B is the midpoint of AC. That was given information. So I'm going to go ahead and write given right there. And also, this right here, step 3, was also given to us. They just told us that from the very beginning. So really, we only have 2 blanks to figure out. 2 missing reasons. Okay, so the first one, AB is congruent to BC. They're saying that AB is congruent to BC. Once again, a lot of times there is a vocab word in the given information. And in this case, you might see they say midpoint. So what I suggest doing, go back to your proof properties sheet, find the word midpoint, and look right there, midpoint, a point that divides a segment into 2 congruent segments. So because it's B is the midpoint, that means that each half is congruent. So that is literally the definition of midpoint. And I'm just going to put MP there to make it short. The definition of midpoint says that if B is the midpoint, then AB is congruent to BC. Okay? And then the last one, so once again, we also were given the information. So step 3 here, I'm going to mark that on my picture. We know that AB is congruent to EF. So lastly, they're saying BC is congruent to EF. Now this is a little bit tricky in here, but if you kind of take a step back, you'll notice that something is congruent to something else. that same thing is congruent to a different thing. Now, if you remember, we learned this. It's the transitive property of congruence. If one thing is equal or congruent to another thing, and that same thing is congruent or equal to something else, then the first thing equals the last thing. So I'm going to go back to here. That is exactly our transitive. And I'm just going to put property of congruence. Now it's a congruent sign, so it's congruence, not equality. But that is the property that proves that these two are therefore congruent. And the last one says 1 and 2 are supplementary, 2 and 3 are supplementary, prove that 1 is congruent to 3. So, first of all, I'm going to kind of cheat here. The given, sorry, make that a little bit bigger. The given is always the first statement. So I'm just going to draw an arrow down there. And that is obviously the given, okay? Now, the vocab word that they use is supplementary. If you go back to your cheat sheet, supplementary means that they add up to 180. So supplementary means they sum to 180. So that is why on the next line, look, they're writing out an equation and summing them to 180. So that is the definition of supplementary. I'm going to abbreviate there. So anytime you see two angles adding up to equal 180, that's almost always the definition of supplementary. Okay. Step 3. I'm going to kind of give this to you, but you might. So if two things are both equal to 180 degrees, then they're equal to each other. And that's, once again, our transitive property. I'm going to make a little bit easier. So once again, if we know that x equals 40 and 40 equals y, well, then obviously x would equal y if they both equal 40. Well, something similar is happening here. This is equal to 180, and this is also equal to 180. So therefore, they must be equal to each other. Okay, that's our transitive property of equality. So over here, I'm going to put the left side of each of those are equal to each other. And that is our, it's substitution, but it's also our form of transitive. So transitive property of equality. Okay, now, you should be able to know this one without even thinking about it. We know that if something equals itself, that is our reflexive property. It's right here. If something equals itself, that is our reflexive property. So we know that the measure of angle 2 equals the measure of angle 2. That's the reflexive. And it's an equal sign, so property of equality. Now, they have to say that because, look, so how do we get from 3 to 5 now? Notice that 1 is still on the left side. 3 is still on the right side. But what's missing is the measure of angle 2. So what they did here, if you subtract the measure of angle 2 from both sides, now remember the measure of angle 2, that's some degrees. So if there's 60 degrees on the left and there's 60 degrees on the right, and we subtract 60 degrees from both sides, they're going to cancel out. That is our subtraction property of equality. If I subtract the same measure from both sides, that's our subtraction property of equality. And that's how we got from 3 to 5. And then lastly, what you're trying to prove is obviously going to be the last statement. So angle 1 is congruent to angle 3. And that is the definition of congruence itself. So if I go back to the cheat sheet, let's find out where that's at. The definition of congruent right here. They congruent shapes have the same or equal measure, and vice versa. If two angles have the same measure, then they are congruent. So to get from step 5 to 6, the measures are equal, therefore the angles are congruent. That's just the definition of congruent. So this is not necessarily easy. You definitely have to think about it a little, but the more and more you practice with this, and make sure that you practice with your formula or your proof property sheet here, you'll get better and better and better. You'll start to see the same things happening over and over. So for example, if you see the word supplementary, and then suddenly two things are being added up to 180, we know that that's the definition of supplementary. If we know two things are equal, you should automatically know that that's the reflexive property, if something is equal to itself. If at any point you see A is equal to B, and that same B is equal to something else, maybe C, then we know that A is equal to C. That's our transitive property. So once again, you'll start kind of seeing these over and over and over, and hopefully you'll get better and better at these geometric proofs. That is all for today.